All right, angles in standard position. So we are looking at first, all right, in geometry, an angle is formed by two rays with a common endpoint. We should know that, right? Now, we haven't really named them other than they're just an angle. So we're going to name the sides to that angle. So we have our two rays here. This one at the bottom, that is like our starting point. We always start with drawing an angle. That's called our initial arm, all right? Right there. And then when we draw how big of angle that we want, that line, that size of angle, that is called our terminal arm, all right? So we have now a side, two sides now that are being named by something, right? It's just like when we went from the Pythagorean theorem, right? It was leg and leg, and then we went to an opposite, adjacent, and what's the other one? Hypotenuse, right? So it's just like this. So what we're looking at is for standard position angles. What do they require? All right? They require, in group A, this is a yes. These in group B are no's. All right? So they have to have this requirement. You will notice that the initial arm is always on the positive x-axis. Always starts on the positive x-axis. All right? So this right here is your initial arm. So you can see that the initial arm does not start on the x-axis. It starts in quadrant 1, and this one is just, out in space, right? That's why they're not considered standard position angles. So that's the first one, is your initial arm, x-axis. Second thing it has to have is your vertex needs to be at 0, 0. Right? It's right here, right in dead center. Here's my vertex of all my angles, right there. This one here is there, but again, his initial arm is not in the right position. Right? And then your terminal arm could be in any of the quadrants. It needs to be in quadrant 1, 2, 4, right? Or it could be an axis, whatever. But it just can't be like floating out in space. Like this one is fine. If this initial arm had been right here, this one would be fine, right? This one, that one's not even. You just have an angle on top of x and y axis, all right? So we're dealing with the x and y axis. Our angles are always going to start in that position right there.
Okay, what's the Q1 thing you wrote?
Okay, so I'm going to review that. So quadrants, remember, are labeled like this. Quadrant 1, I'll put the word up here, quadrant Q1, right there. Oh, and I should use Roman numerals. It is more official, Roman numerals. And the reason why quadrant 1 is in the top corner is because anything that's in that quadrant is positive, positive, right? If I was to graph anything, my coordinates would be positive, positive, because this is a positive, that's a positive. Anything that's graphed in there is positive. So when I go this direction, quadrant 2 goes in that direction, quadrant 3 is down here, and quadrant 4 is right there. And these are going to become important, especially we're going to be working with sine, cos, and tan. And sine, cos, and tan are positive and negative in different quadrants. Okay, and we're going to get to that today. So every standard position angle always starts right here. Okay, and you will notice that they use the little Greek thing, theta. Right? I am going to use that. I'm not going to use like angle A or angle B or angle C or anything like that. I'm going to use theta. Okay?
Your phone is ringing.
Can you go grab it, please, for me? In case there's something I need. I'm going to pause for a second. we have a standard position angle, always starts on the positive x-axis, and it will rotate counterclockwise. All right? So we can have an angle that's in quadrant 1, we can have an angle in quadrant 2, 3, and 4. What is the biggest angle I can draw?
360.
Exactly. So we're going to go a little less than that, 359, that sort of thing. So as soon as I hit between here to here, right, and it talks about it right down here, in quadrant 1, anything from 0 to 90 degrees. 90 to 180 degrees, 180 to 270, and 270 to 360, all right, are our 4 quadrants, and that will determine what quadrant it's in, all right? So, and they give you another little picture of what a standard position angle is, okay? So we have this, right, you'll have acute angles in quadrant 1, you'll have obtuse angles in quadrant 2. What kind of angles do I get in quadrant 3 and 4?
Obtuse.
Vertex
Oh,
or rad.
Right. I don't know.
Reflex?
Reflex.
Reflex. Anything over 180 is a reflex angle.
I was close.
Okay. All right. So we're good there so far. We all know where a standard position angle starts?
Yes.
X-axis. Good.
Flat axis.
All right. So we're going to sketch some angles.
Yay.
All right.
You don't need a grid though.
Well, no, you're just going to, I'm going to use a ruler because you know I like rulers.
You know what?
That's an angle.
So I'm going to draw my X and Y axis. Now these just need to be, up until now we've used a protractor and I don't think we need a protractor. I think we could probably,
Graduated from the
well, it's to get a picture of where it is, right? If it's a 36-degree angle, what quadrant am I going to be drawing it in?
The bottom left one.
Right, quadrant 1. I'm going to draw, will I draw an angle that's super huge? No, right? I'm probably going to draw, something a little smaller, right? I'm going to make sure I put so I'm always going to draw my X and Y axis with no arrows, and then whatever angle I want, I'm going to put arrows on it, okay? Yes, because that's where my initial arm is, right? Because that's my part. Well, there is rulers in the back
That is way too far.
Oh, look at this. I have a ruler that's just sitting here, brand new and purple. I took some options home for my daughter, and she didn't want the purple one. She wanted the clear one.
You should know that.
Clear. Oh,
Shattered.
She's now, 13, so,
The sass is coming on? Or?
All right, so sketch each angle in standard position, so I did that. State the quadrant in which it is in, so it is quadrant 1. Oh, quadrant 1. And I also have to finish it with the little angle that goes like that. And I want to write theta equals 36 degrees. And
Math.
210. So this was a, where does 210 end up in?
Third one.
Third one. How far into that?
Pretty like not very far.
Well, how many degrees? 30 degrees, right? Because 180 is here, 180 to 210 is about 30 degrees. So let's draw about a 30-degree angle. Okay, I'm going to do a different color because I do have different colors. Let's go with green.
That is so interesting for you.
And we're going to go like that. And then this is my initial arm here. All right, I'm going to make sure that I put my arrow on my initial arm, right? And I put my arrow on my, what's that called?
Terminal.
Terminal arm. What else do I need? Right, I need that. And I need theta equals 210 degrees. And I'm in quadrant 3.
Wow.
Isn't that beautiful?
No.
That is actually pretty good.
Yeah, it's not bad, okay?
Yeah.
And, okay, well, the lovely thing about it is when you're studying, all these are online too. So 315. So where would I put 315?
Probably in the fourth quadrant.
And how big would that angle be?
45.
So if you're not sure, you could do 360 minus the 315, right, which would give you 45. Or you could do 315 minus the 270, right, because this is 270 down. Oh, you can't see that. 270 down here. But I would use the 180, 360 thing, and I'll show you why 270 and 90 generally don't ever get used. Use this. So I want a 45 degree. What's a 45 degree look exactly as?
Probably like 45.
Half. Yay! And like that. Where do I put the arrows? I need an arrow on the x-axis. I need an arrow there. I need
Quadrant 4.
and I need quadrant 4, and I need to say that theta is equal to 315 degrees. Can we draw standard position angles?
Sure.
Do we know the parts of a standard position angle?
Sure.
Fabulous. All right, let's move on. So these standard position angles create reference angles. All right? So a reference angle is the angle that each of these, I'm going to just flip back here a little bit, that each of these create with the x-axis. All right? So if I'm looking, which one do I not have? I don't have one in the second quadrant. Let's draw just one in the second quadrant. Give me an angle that would be in the second quadrant.
91.
No.
Yeah.
Give me like, let's go 120. 120. Let's do, so this was C, let's do a D. Because I want it to be like actually can see it in the quadrant.
What are we doing?
Hey,
So we're going to draw a 100-degree angle. Was it 100, 110? 110. 120? Okay, 120 would give me what?
60-degree angle.
60-degree angle? Okay, so 60-degree angle right there, right? And this gave me 100 and theta equaling 120. And that. Okay. You know what, Nicole, you are like you gave me like the perfect, and this is quadrant 2, the perfect answer to what I'm going to next ask. Okay? What is the angle between this terminal arm and the x-axis?
60.
60 degrees, right? This one right here is 60 degrees. Right? What is the terminal arm and the x-axis in this one?
45.
45 degrees. Okay? What is the terminal arm and the x-axis in this one?
30 degrees.
30 degrees. And what is the amount of degrees in this one between the terminal arm and the x-axis?
Which way?
The
Other way. Right?
No, it can't be. You can't, that would, straight down to the x-axis.
36.
36. So in this case, theta is 36 degrees. These ones that I've written in pencil are called reference angles. And I denote them with a theta, but with little tiny r as a subscript. Okay? Like a little r. They're subscripts. Now, theta r. Theta r. Like that. Now all these reference angles are all different. But what happens if I had 4 angles, 4 standard position angles, that all had the same reference angle? Okay? So I'm going to grab a piece of paper. And we're going to pick a reference angle of 30 degrees. Okay? So I'm going to draw them across here. You can just watch this. Okay? So where did my ruler go? Oh, there it is. Okay, I'm going to draw 1. Here's quadrant 1. I'm going to draw another one that looks like that. Another one there, and one more. And we are going to draw reference angles that are 30 degrees. Okay? So if I'm in quadrant 1, and it's always a reference angle is, so a reference angle is always acute. And it has to go to the x-axis. It never goes to the y-axis. The y-axis is really nothing. The 90, 270, really not a big deal. So if I want a 30-degree angle in quadrant 1, I'm going to draw a 30-degree angle right there. And in quadrant 1, what did we notice about the reference angle and the actual standard position angle? They were exactly the same, because the nearest x-axis, right, is right there.
So you always go to the nearest x-axis?
Nearest x-axis, which is always down, okay, or up. So I call it the bow tie, meaning that if I was here, it would go down to that. If I had an angle that was in this quadrant, it goes down to that. If I have an angle that's in this quadrant, I go up to that one. And if I have an angle that is in this quadrant, I go up to that one. So it creates a bow tie.
Has a lopsided bow tie.
Yeah, well,
I think it's perfect.
all right. Are all these angles acute? Yes. Now, are all the standard position angles acute?
No.
Which is the only one that would be acute?
The first one.
First one, right? Because that one's this one up to there. My standard position angle in quadrant 2 is from here to there, right? So I draw a 30-degree angle in quadrant 2, right? My theta angle, so this is theta equals theta reference. So my reference angle is right here, but my theta angle is right there.
Well,
Okay? And if I draw it in this quadrant, no, I had to use purple. If I draw it in this one right here is my reference angle, and this right here is my standard position angle, my theta angle. And if I draw it over here, where's my reference angle?
Right in the middle.
Right here, and this is my standard position angle. Now, why would that make a difference? Well, sine, cosine, tan actually repeat itself. They mirror each other in the 4 quadrants. So really, the same value is going to show up. So let's say if we use sine, right? This right here, I'm going to use sine, this is going to be 30 degrees, right? We all agreed that this was a 30 degrees. This is 30 degrees. This is 30 degrees. This is 30 degrees. So this one here is both 30 degrees. What's this angle here? What's our standard position angle? 150, because these two angles have to add to what?
180.
Right. All right. So what's my standard position angle in quadrant 3 here? 210. 180 plus that 30. So 210. And what's my standard position angle in this quadrant? 330, because 360 minus that gives me a 330 degrees. Oh. Okay? Now I'm going to take theta angles, and I'm going to go. First quadrant, we said sine 30. Second quadrant was sine 150. And I'm going to use sine. You could use tan or cosine or whatever you like, but I'm going to use sine. I'm going to go sine 210. And I'm going to go sine 330. Okay, now I'm going to take my calculator. And you can take your calculator too, so you can see it on your screen just as much as me. Make sure that your mode is in degrees.
What if I don't do that?
You don't, you're working something called radians, which will take in pre-calculus 30, and there's only like 6 and
What if I don't take
6.28 radians in a circle, so, all right. Yeah, he was all messed up, yes.
Why did you do that?
I did not.
How long did he go when it?
It wasn't very long. All right, so let's go with sine 30, and we get the decimal place, 0.5.
So what?
That is just the decimal of sine 30, all right? So sine 150,
Put that.
sine 210.
Negative 0.5.
Mm-hmm. And what is our prediction for sine?
Negative 0.5.
Yeah. So by doing this,
What did that mean?
so in quadrant 1, sine is positive, but all of them are the same. So they mirror each other. The reason why they mirror each other is they all have the same reference angle. So all of these angles right here, all of these angles that we have up in here, all these reference angles, all are exactly the same. So whatever angle you choose, right? If you choose another angle in another quadrant that has the exact same reference angle, all of its decimal values will be exactly the same. All right? And the reason for that is in science, you've probably done waves before, right? And you may have even referred to it as the sine wave. Has she ever referred to them as a sine wave? The science teacher?
Every once in a while, yeah. Maybe
The sine wave?
Maybe like once or twice.
So a sine wave, essentially, I'm just going to go, a sine wave looks like this. All right? Starts at 0, goes up to the highest point, down to 0, goes to the lowest point, and then back up again. All right? So at 0, put in sine 0 in your calculator. What do you got?
0.
0. All right? I'm going to go with, all right, so sine 0 would be right here on an x and y axis. So I'm going to, so here's 0. It would be a 0. What happens if I go sine 90 degrees? You get 1. Right here. There's 90 degrees. So what I'm doing is just taking it and putting it out on a linear graph. Okay? So what happens when sine gets to 180? It goes to 0, back to 0 again. What happens when it hits 270? Yeah, you get -1. All right? And then what happens when you go back to 360? It gets to 0. Now, 30 is where on the wave? 0.5. So 30, 60, 90. Look at that. 0.5. Where is 150 on this graph? Right, 120, 150. Look at that. 0.5. Where is 210 on this graph? 180, 210, and then what does it go? 240, and then 270. There, my graph, 210, right there. Yeah, mine's out a little bit. My graph, if I used graph paper, it would have been out better. And where's the last one? 330? Right there. So that's taking these pictures and sticking them on a linear graph tape. We're going to get to these in pre-calculus 30 and how we can manipulate what this graph looks like. We can shrink it up, we can stretch it out, that sort of thing. So we did that with, have we done that? No, we didn't. We haven't done that. We're going to do parabolas. We're going to squish them up and stretch them out and all that sort of stuff. We haven't done that yet. But that's what it looked like. So do you notice where things start repeating? Every single time. And any of the angles between 0 and 360, will they ever get above 1 or negative 1? No, because your wave always stays within the 1. All right? Tan is the only one that goes a little funky. Tan has some, because tan is actually sine divided by cos. All these. Cos looks like this. I'm just going to use a different graph. It actually starts at 1, goes cos 0. You'll start it at 1. And it does this. Oh, crap. What did I do here? Yeah, and then it's going to go back up, and then right there. There we go. He's backwards. He starts up, goes to the bottom, and then goes back up. And every value that you put into your calculator, all those little decimal places that when you punch in sine 30, cos 1, cos 45, all of those will have matching things. So, does that make sense? Where the reference angles come from. So, sine, cos, and tan repeat themselves in every quadrant. Depending on what quadrant they're in, they will be positive and negative, right? Sine is positive in the first 2 quadrants, negative in the last 2 quadrants, in quadrant 3. Where will cos be positive? In quadrant 1, but then it goes negative in quadrant 2 and 3, and then comes back in the positive for quadrant 4. Okay? But in this chapter, we're not going to look at what it looks like linear. That's another chapter. What we care about is, can you draw it in the 4 quadrants? Can you identify what a reference angle is and what that standard position angle is? All right, so what do we got for, I know this is a little long. So let's go to page 4. They have show you the little, they used a 20-degree angle at the bottom. I used the 30-degree angle. So what I just did is all right there on the bottom of the page. Okay? So what they want you to be able to do is they will give you a standard position angle. So anytime you see theta, you standard position angle. They want you to determine what the reference angle would be for each of them, sketch your standard position angle, and then label the reference angle. So they give you an angle, a theta angle, a standard position angle that's 130. Where would I put it?
34.
Quadrant?
2.
Quadrant 2. Okay? So you're going to draw it in quadrant 2. Okay? I'm on page 4. Okay. So where does 130 go? Quadrant 2. How far into it?
40.
Okay?
So it'd be,
What would its reference angle be?
reference angle would be 50.
50. All right. So I always like to think of the reference angle because nothing really goes to the y-axis. So I don't tend to use the y-axis. I always think of how far is it to the next x-axis.
Yeah.
Okay? Because then if you start thinking of y-axis, then you kind of, sometimes the bow tie goes to the x-axis. It never does this. Okay? So it's always, so I need about a 50-degree angle. So I'm going to label my 2. Where do I put my standard position angle, my theta angle? Starts at x-axis, goes to there. I'm going to label it theta equals 130. What else am I going to fit? My reference angle, theta r, and I'm going to say it's equal to 50 degrees.
And then your quadrant.
And does it ask me what quadrant? No, I don't need it. No, it didn't ask me. Okay? All right, B, 300 degrees, right? We are in quadrant 4 with a reference angle of how big? 60, right? So I'm going to draw a 60-degree angle, approximately. Where does my standard position angle go? Where does it start?
That's 0.
It starts at 0, or the x-axis. It rotates all the way around to that terminal arm, right? Theta equals 330. And I'm going to label my reference angle at, 300. And my reference angle at 60 degrees. Okay?
Okay, I see.
You are going to do the next two for me and bring them to me.
Yeah, how?
Okay? There's,
Mine was blank.
pause the video. I think the last thing we're going to tackle, does it turn on?
You know what I need?
Was right here. So let's just put a reminder how to calculate our reference angles in this little thing. So if I want to, remember in quadrant 1, our theta angle is just our angle. Our theta angle actually equals the same as our reference angle, right? In quadrant 1.
Yeah.
So whatever our standard position angle is, that's our reference angle. What? Oh, yes. In quadrant 2, right? So my theta, and this is my, right there. So in quadrant 2, right? How do I find my reference angle?
Like 37 feet.
How do I find this angle here? Right? I go 180
180
minus theta. Good. This is theta, right? If I've got it in this quadrant, there's that. How do I find my reference angle there?
270.
Never 270. 90 and 270 never come into the picture. Never. Because if you're using 270 and 90, what axes are you using? The Y's, right?
So 180.
The number minus.
Right. Theta minus 180,
Sure.
right? Will give you your reference angle. And if I want something in quadrant 4, again, it's going to,
360 minus 30.
right. So my reference angle is going to be 360 minus theta. All right. Now, I think I'm just going to flip through a little bit. There is a couple little other things. There's calculations to deal with this, like we can use them in problems. I'm not going to do that at the moment. I'm going to give you the questions in the assignment that kind of correspond to graphing these kinds of things in just a little practice. And then we'll do what you use these for in the next part, right? So you're going to do question number 1. What is each angle a standard position angle? And you can just tell me whether it's yes or no. We're on page 8. 8. Just tell me yes or no is the standard position angle. Without measuring, match each of them. So there's A, B, C, D, E, and F, and there's little A, B, C, D, and F. So you can look at them and just write the letter next to them or whatever. You got that. You will need paper for this assignment. I didn't give you any. This one doesn't have any space to put them. Because in what quadrants does the terminal lie? So you just tell me the quadrant. Here in number 3, you probably put it right on the page. But number 4, when you sketch them in standard position angle, please put them on paper. This one's going to need paper. Okay, use a ruler. I do not want, I am okay with you eyeballing them, unless you want a protractor. I can give you a protractor. But I do require a ruler. Please use a ruler. What is the reference angle for each of these? Again, you can probably just put it on here. Determine the measure of the 3 other standard position angles if you have a reference angle that is 45 degrees. So they're giving you reference angle in quadrant 1. what would all be all your standard position angles in the other quadrants? So think back to this, right? 30-degree reference angle in quadrant 1 was 30 degrees, but a 30-degree reference angle in
Oh, I see.
quadrant 2 gives me, I want to know that. I want to know these numbers. So if I have a reference angle that is 45 degrees, right? 45 degrees in quadrant 1, what will the other standard position angles be? Okay? So you're technically going backwards from this picture. They're giving you these, and they want you to find these little things right there. Okay? Number 6, and what we got for time? Yeah, that should be enough.
Still
Okay.
saying 3 minutes.
No.
Supposed to get.
No, we got 10 minutes. It goes till 10 o'clock, right?
What? That's
Yeah. You sure it
So
goes?
8 minutes.
Or maybe it's, or is it 9:55?
It's hours, 9:55.
Is it 9:55? Anyways, yeah, up to there. That would be lovely.
8:50 a.m. to 9:55 a.m.
Oh, okay. So, you'll be fine.